Hello, everyone, and welcome. It is Wednesday, and it's Chondrule Day. Pat, calm down. Easy, boy. Easy. As soon as I realized it was Chondrule Day, I was like, "Oh shit!" No, so we're actually going to strive to keep it a more of a beautiful show today, as far as showing you how beautiful meteorites could be with these things called chondrules that make up. Chondrites. So that's a whole complex thing. No. So we're going to talk a little bit about what they are, how they're formed, how they change through time and pressure, and blah, blah, blah. But mainly we're just going to be looking at some beautiful meteorites today. Going to be telling stories when they do have stories. So I'm going to jump into my show and tell real quick. All right. This first one, this is a single kilo stone classified as an L3, and I really wish it had a little bit more classification, subclassing on it, but this one is just beautiful. So basically, everything you're seeing there that's round or semi-round are chondrules, and they are suspended in a matrix. And this doesn't have that much metal in it. You really can't see that much metal, but this is one of my more beautiful pieces as far as showing off chondrules. This side is directly off the wire saw, not polished. And Pat says it's better for a microscope when it's
It can
not
be. There are
polished.
things that you can see that you can't see on a polished surface.
So this one is, and Pat, maybe you can, if you don't mind, could you share some information about subtyping? Because I'm looking
Sure.
at this and 1,000-foot view because we're trying to make it easy for people. But this is an
Right.
L3. Now there's a lot of money and science that goes into making sure that this one right here is a L 3.15. So
Right.
can you give us a aerial view of what we're looking at, please?
Yeah, sure. So all chondrules start out as threes, and they actually start as 3.00s, but they all start out very fresh. You notice how well defined the edges are of the chondrules. And so there's a special testing looking for chromium oxide in a category of chondrules that lets them know just how primitive they are. But chondrules basically go from type 3 up to type 7. And each time they go up a type, the edges get fuzzier and they get recrystallized. And that's a function of them being buried in a small planet and experiencing time under heat and pressure. Uh, and then, so we started out with 3 through 6, and then later they added 7. But they found out that in the type 3s, there was actually a lot of difference amongst things that are all type 3. So they added more clarification and new criteria and are able to split from 3 to 4. It goes 3.0, 3.1, etc. And then that special one that Topher just showed us is a 3.15. So that's amongst the most primitive of the chondrites in that they are like they started out. They haven't been changed.
Why does it start at 3 and not 0 or 1?
Because the fellow who wrote the paper started that way. No,
Exactly.
there's a very famous paper from 1967 that set out HLLL and the numbers 3 through 6. So normally for ordinary chondrites, we use 3 as a starting point, and then it goes up with more time under heat and pressure. But the scale also goes the other way too. When you start at 3 and then go down to 2 and then to 1, instead of the chondrules getting messed up because of heat and pressure, they get messed up because exposure to liquid water. And that's aqueous alteration that happens on small bodies that have liquid water, which water is kind of important to life.
So I think what I'm hearing is we can make up any reason we like. So I'm just going to assume the guy who wrote the paper was a big Dale Earnhardt fan. So he started with fair enough.
That's possible, but the paper was written in 1967, so I think it had to have been Dale Senior.
Well, we'll take that too.
I wonder if possibly if they started at 3 for thermal metamorphism grade because like maybe he was leaving room for it to go down
Yeah.
further on the
How
line,
do you know
like
you
2 and
found the
1.
lowest?
Well, yeah, both, so the whole thing 1 through 6 was all set up at the same time. And for the ordinary chondrites, we don't see a lot of aqueous alteration. Some of them, like
Yeah,
some
because that's
Arcona,
primary.
have some, but yeah, so
Well,
starting at
I'm
3
gonna
was arbitrary.
put the science on pause for a second, and I'm going to share with you guys something that I'm a big fan of gifts, and we have a very talented person on our crew that joins us not often enough. But who is Outer Reach Meteorites? You guys know? Preston Allen. Yeah.
Yep.
So these are his cards. He did something the other day that blew me away. This is 3.34 grams of an LL3, brand new classification. But look what he decided to do with the 3.3 grams. This is amazing, guys.
Oh, scale cube?
A scale cube.
Wicked awesome.
Made
And
out of some absolutely amazing meteorite material.
and it is dead nuts on.
Yep.
That's incredible. It's so hard to make cubes.
Yeah.
And to
I
get them
mean,
square and
when you
everything.
can
Yeah.
measure 3 axis and it's 0.99, I was blown away. I left him a voicemail like how I don't know what kind of wizardry you're doing, but this
That's
is
a beauty.
ridiculous. Yeah, so I can actually use this. Look at this. I could use it as a scale cube if I wanted to.
That's really awesome.
Yeah.
Is he
So
gonna
this
make
was
more?
he has a bunch of them. So yeah, definitely reach out to Preston Allen. And hold on, let me get his card in here. Gotsta. Outer Reach Meteorites. It's NWA 17875. It's an LL3. I like to read the write up on it to see if it's any subtype potential. But absolutely beautiful material and dead nuts on 1 centimeter scale cubes. So I'm absolutely blown away by that. And Preston, I wanted to come on camera and say thank you very much. I left you a voicemail, and I'm sorry. I feel like I was a little teenager talking to the Beatles. I was, ah! But thank you very much. I super appreciate it. And before I send it back to the crew, I want to show off one more thing because we've been talking about we've been showing off chondrules all this time, and they're super, super tiny, but they're not always super tiny. Pat, could you highlight me, please?
Yes, sir.
This is one that I was super fortunate to be in Tucson with, and a buddy of mine, Travis, and I cut this rock in half. He kept half, and I kept half, and we found that in it. At least, yeah, about 13, almost 13 millimeters. Yeah, it's massive when you compare it to what we were looking at in these other ones. So I just wanted to point that out that, hey, size isn't everything. You can be big, you can be small. Chondrules come in all shapes, sizes, and forms, and are all beautiful. Dave Pinsky, you're beautiful. Can we go to you? I don't have a segue.
Why, thank you. Let me share. So this is NWA 16739. It is an LL3. And it's got some really nice, there's no subgroups in this, which kind of bums me because I really think this is very close to the lower end. Because, like you said, when you look at the chondrules, they're very sharp edged.
Wow, there's no matrix.
No matrix. As a matter of fact, the chondrules there's little ones here, here, and here. I couldn't find a lot of matrix. The chondrule size on this is generally small, but that just doesn't mean they're all going to be small because look at
Oh
this.
my God.
Yeah, this one is just a little bit smaller than the one you showed. And then there's this one here amongst
Oh,
these smaller ones.
That's a great sample. That's unique.
Yeah, it's really, yeah, I saw that and said I had to have it. And it's just beautiful chondrules. This is probably the best uh, L3 I have.
Mhm.
There's not a lot of metal on this because it is an LL, which is low iron, low oxidized iron. So the general, that's the lowest of iron of the chondrules. But still, you get some of the rusting. But what it does is it gives it a little bit of color,
Mhm.
which you can see there's some staining of rust in and around here. Here, you see a little bit here. When the stuff from the solar system started to clump together, some of these formed and they got flash melted and then they formed in little balls that would clump together and form bigger bodies with some of the iron in that in the matrix. And literally, you're seeing planet formation right here uh, from the very beginning, which is what got me into this completely.
That's amazing. Yeah, fantastic. Thanks for sharing that one with us. I
No
really
problem.
like the fact that it had really, I mean, no matrix. It was all probably low subtypable chondrules.
Yeah.
And you turn it over and you have these two big ones on there. Like, yeah, they got in the wrong meteorite. They didn't know.
Well, yeah, no, I should have sent it back. It was defective, you know.
Talking about things that are defective.
Yeah.
Anthony, how you doing, buddy?
I'm good. Not
I'm gonna stop the segues because they're not working. Welcome, buddy. What do you have to show us?
okay. So I hate to break it to you, but I'm changing up my share this week, and it's photos. But what I'm doing differently is I've uploaded them onto one of my drawing apps so I could highlight the areas that I like.
An interactive photo. I will accept it.
Yeah. So let me share here. So this is Dar El Kahal. And that's a, let me see here, an H5-6. So a lot of metal. You could see all these like metal everywhere. It's all over the place. It's pretty cool. But then when you go closer, right, you can see some of those well-defined chondrules here. But it's pretty packed full of them. And a few of these that I'm showing I got early on when I started collecting. All right, so the next one we got here, this is NWA 791. And you could see the difference, right, between just the amount. And I think, a lot of them disappeared over the time of that asteroid or body's life. But, there's still some cool ones, big ones there. This is also, I believe, an H something, maybe. 791, or actually it's an L6, damn. But there is a lot of metal in there as well. Let's see, let's keep it moving here. So this one's really cool and it's
wild.
pretty unassuming. This is NWA 8008, and that is an L4. But it's got a pretty high weathering grade, I believe. But it's pretty cool. There's a lot of interesting stuff going on here, including, this really huge chondrule right there. Looks pretty well intact. And then, it's pretty small. This guy, it's different than the rest. And I was able to take some okay photos of it with my microscope. Let's see here. So here's the first one.
oh yeah.
Ooh, nice.
And it's definitely, got this glassiness to it that's different than the rest. It stayed intact. It looked like it didn't change as much as everything else. And then I got one more a little closer. So it's really cool. It's so fun to go through these slices, at higher magnification and see stuff that, you completely miss with just your eye.
Absolutely.
So that was a fun one. This one,
What you can really see in that picture that you just showed was the different composition for sure of the chondrules. Like just because it's in the same slice doesn't mean anything. Just because they're right next to each other doesn't mean anything. They could be formed differently. They could have different compositions, different chemicals, minerals. I mean, and that one looks like that one reminds me of a deviled egg for some reason.
yeah, totally.
Wow.
This is NWA 17267, and it's marketed as an equilibrated chondrite. But it's really cool. There's a ton of stuff going on here. I mean, this right here, this whole dark patch is really interesting. I don't know exactly, what that is on the chemical spectrum, but it looks like one big, piece of something.
Yeah, Anthony, I think that is probably a carbonaceous inclusion. It has a CM2 sort of look to it, and unequilibrated chondrites is code for type 3. They mean the same thing.
Okay, gotcha.
And the type 3s occasionally have carbonaceous inclusions, and that looks like one.
Yeah.
It really does, yeah.
This part right here is also very interesting. The texture, of it. It's like there's a few other places where it looks similar to whatever those chondrules were. I think they were part of something similar, and then they all ended up in this.
What about the one under the one you just circled? It has a bullseye on it.
Yeah, this thing. Yeah.
Oh yeah.
And then the one above that by 2, like both of them have something internal in them.
You talking about this?
No, straight.
No, in
up
between.
and towards 1 o'clock, but like a snowman. Yeah, that one and the one in between. Like they all have like weird things. That's wild.
They're busy chondrules. They're doing something.
Wow.
Yeah, and you could just get lost for days in this thing. I know this is about chondrules, but this was an end cut, so this is the the outside of the meteorite. Anybody want to guess what it is?
I know. It's a subtype 3.6 witness fall.
Abupanu.
Yeah. Boom.
Boom.
Do me a favor, go back to that reverse picture if you don't mind, because I mean we've been dancing around it, but for people who are on YouTube who don't know, chondrules are they're round. I mean, a perfect chondrule would be a round sphere. Well, we're cutting them, so whether we're cutting them very sharp or like very fat, right in the middle, very narrow, you're going to see them growing and changing in size. What you're seeing on this side is you're actually seeing the 3D chondrule sticking out that hasn't been cut or polished at all. So you can literally see the realistic complete size. Does that make sense?
Mm-hmm.
Yeah.
All these little pieces. Now and then the interesting part, right? It's like there's a ton to really look at here. I really like this chondrule right here with like the metal all the way around it. And then this big chunk, which is made up of all these other chondrules, it looks like. It's super interesting. This one has like all these like tightly packed chondrules around this main chondrule. But this is another one of those where you just kind of get lost in it. And then we got these darker inclusions, right? What are these?
Well, right above that, it looks like a sulfide inclusion.
Yeah, this.
Yeah, that's beautiful.
Yeah, and you could see kind of the metal in there, and it's starting to rust out a bit.
I like that really white one on the bottom there. No, it's like in the middle.
Here?
Yeah.
lastly, you know, I got a slice of a yende. This part is pretty cool. It's like these two slammed into each other. And, you know, these are pretty cool to look at. This is a pretty small piece. It's, I think it's like 7.9 grams or something.
It shows all the cool stuff for a yende.
Yeah, definitely. I was not disappointed when I received it. But yeah, that's what I got for y'all. Thank you.
Cool, Anthony. I appreciate it, man. That interactive show and tell was definitely worth it, man. You're raising the bar as one of the newer guys, constantly raising the bar. I love it, man. Mike Kelly, what do you have for us, buddy?
So you can't talk cool chondrules without talking about some rare meteorites like the bencubinite group.
Mm-hmm.
So chondrules that are made completely out of metal. So this is Argoin 001 and Gujba.
Wow.
And you can see the chondrules themselves are 100% metal. They're type 3s. And the matrix they're in is silicate, which is backwards for a lot of things. You usually have oxides in your matrix and more crushed up bits between the chondrules. So just wanted to share those two off. Those are two of my better looking bencubinites where the chondrules are not squished, as you were mentioning. Sometimes they get deformed. So they're pretty pristine type 3s.
Those are pretty.
Mike, thank you very much for showing those off. I was really hoping that someone was going to show Gujba, bencubinite, something, because when I was talking earlier about the different types of chondrules, it's like I didn't want to say that. Yeah, and some are made of metal. I'm like, well, I'm glad you did, man.
No worries.
Let's go to Marissa. How are you doing, beautiful?
I'm good, and can't have a chondrule party without thin sections.
Nice.
The chondrule party. Whoop whoop.
Wow, stunning.
So this is an unclassified chondrite, but this thing is beautiful.
Yeah, when I said that we're going to have some art on today's science show, I was hoping the wink, wink, nudge, nudge was like, Marissa, you better put your hand up.
I've got the 1/4 wave plate on this.
That one you're on right now, purples, pinks, violets, purple, like they all match. They all go together, you know? Then you go up and there's yellows, greens, cyans, going into a little bit of blues, limes, and it all works.
Yeah, I've noticed that quite a bit when I'm looking at olivines, and it's usually on, like, I'm assuming fault lines, cracks, or weathering, staining.
Wow.
And,
It's
you know,
awesome.
Marissa's photos are, you know, beyond science. They're art and science at the same time. And Marissa does a lot of composition to get the colors in pleasing patterns. But it is interesting that some of the colors go
Just,
together like that.
They line up. Yeah.
Yeah.
That one big round chondrule has such a well-defined, sharp outer edge for only 60% of it, and the other side's screw it.
Yeah, to me it looks like Pac-Man.
Nice. Yeah. To me, you know, it looks like the Fortress of Solitude where Superman lived.
And the details in there are just amazing.
Yeah, I'm pretty sure that this is a cryptocrystalline chondrule, and it got these pieces of olivine, but they're shards, and they're like all pointing to the center of the chondrule somehow.
Yeah, that one is a nightmare for trying to figure out how the chondrule formed. Because like Topher said, it's got this beautiful rim around it that's so well defined, right at the last little bit of the edge. And then the rest of it
not to be seen anywhere.
Long cooling time during accretion.
Yeah, that's a very clean edge. This one I thought was so cool. It's got little bubbles.
All the little bubbles in
In
the
it.
individual olivine grains. Yeah, that's so cool.
What exactly is cross-polarized light? Like, why is it giving this reaction with this kind of light?
When I look at a sample with cross-polarized light, a full slice, basically you're removing the reflective light that your eye sees. So if you're trying to look at fish down in a pond and all you can see is the light reflecting off the top of the pond, you can't see the fish. If you remove the reflection of the light off the top of the water, you can then see down past that reflection and see the fish. And so it's very much the same thing with my meteorite. If I remove all the reflection from the shiny polish that I've given it, now I can see the chondrules.
That was a great explanation. I really appreciate that.
Yeah, totally.
When Topher set out the theme for the meeting today, the theme was Chondrules in 3D. So this is a 3D chondrule. So as Topher mentioned once already, you know, we mostly look at excuse me, slices of meteorites, and when we see them, the chondrules are usually round or sometimes squished into shape a little bit, but these things really are three-dimensional spherical objects. And the 2-second definition is that in the protoplanetary disk, there was a lot of dust of silicates, and that dust gets together, makes a dust bunny, then somehow it gets heated and into a droplet and then cools. And sometimes cools fast, sometimes slow. And so that's how we see a lot of the different types of chondrules. But this one is actually a chondrule that is sticking out of the surface there. So this is one of those rare chances to see the chondrule as a sphere. This is a broken surface. There, you know, there is fusion crust there.
Yeah.
And then this is a broken surface that still has a lot of the dust from the desert. And
it has another one right there too.
Exactly. There's a second one we can focus in on there. And they don't look as pretty in 3D as they do in slices, or especially in thin sections.
That's a matter of opinion. That's a matter of opinion.
Yeah, beauty is in the eye of the beholder.
Yeah.
And
I love seeing them external like that because it really drives home how big the actual physical size of that chondrule.
Yes. Yeah, and that one we were looking at was about 8 millimeters long. And then this is another, it's a whole stone, so hasn't been cut yet. And this is a very mixed up polysomatic barred olivine chondrule. And this one is actually 19 millimeters top to bottom.
Wow.
That is a 3.00. Yeah, that's how chondrules all start, is 3.00, and then they're exposed to heat and pressure, eventually become a lot less defined, and then eventually in type 7 they disappear because they're recrystallized.
3.00 in the house. Thank you very much, Pat. I appreciate it. We have 2 more people for tonight, and the first one who's had his hand up for quite some time, Ben Fissler. Ben, what do you got for us?
These are 3D chondrules.
Oh yeah.
Bring it in a little closer if you like. The like this one here is 6 or 7 millimeters. The material that surrounds the larger ones there's chondrules that are down to less than a millimeter, but the larger ones you can see some more sticking out. Those are all 6 and 7 millimeters. They're decent size. Look how thick the crust is too. Oh, and the reason I picked this out in the first place, it was unrecognizable. It was completely covered with clay. No magnet, none of my Neos would pull it. So it's also not magnetic or extremely low. After cleaning it, it was just oozing chondrules, so had to have it.
That's beautiful, and I can tell you how to keep it safe for many years to come. And that would be keep it away from Pat. Yeah, don't ever let your low Petros. Sorry,
guilty.
man.
Guilty as charged.
I'm still a little salty. My bad. Stephen Amera, how are you, my man? Are you awake?
I'm wonderful. Yeah, I'm still awake. Surprisingly.
Very good to have you, man. He's in Boston, so
Yeah,
late
buddy.
there.
Now,
Here we go.
Chondrule party can never be complete, right? And I'll add Rumarudi to that one.
Yes.
This is a beautiful Type 3 Rumarudi. It's unclassified at this point, but one of the things that stands out about quite a few Rumarudis is the chondrules tend to be pretty white. Now, this one right here, this is one of my classifications. It's a CV3 OXA. It's the first one that got that designation.
Nice.
As you can see, there's absolutely stunning CAIs, and that CAI in particular, there's almost like a pink purplish hue to it.
Yeah, it looks like there's an inner and an outer layer and all of them.
Yes, yeah, they're gorgeous. Beautiful CV3, beautiful chondrules. Then we move on to some unclassified Type 3 chondrites. This one's loaded up. Quite a few igneous rims. We have some around a couple of the chondrules there.
Nice
Great,
bullseyes.
yeah, great chondrules in this one.
Wow.
And it's very colorful from that laminate staining. Here's another beautiful Type 3 with the very white chondrule over there.
A bleached one too.
Yeah.
Look at that bleached one.
And then one with a carbon in it. Like zoom in again.
Oh yeah, the carbonaceous inclusion.
Yeah, the
carbonaceous
carbonation, and
inclusion,
then down below, there's actually a chondrule with what looks like maybe a carbonaceous inclusion in the chondrule.
Yeah. Oh, right there. Yeah, I see what you mean. I'm thoroughly obsessed with with chondrules. This was one of the first Type 3 thin sections that I made. This one came out really good.
Yeah.
And it has a nice quote megachondrule or even compound megachondrule.
Yeah.
Another thing about this particular slice, as you can see, many of the chondrules are porous. Pat and I have had a bunch of discussions here and there about porous chondrules and Type 3s and how it could potentially lend to its primitiveness. This is a large, almost kilo stone that I picked up from NWA, but you could tell that this is going to be a very cool Type 3 once it's cut open. A lot of chondrule plucking on the surface, but that should be interesting. And last but not least, we have PBSA1. And yes, that's the work name for the Type 3 chondrite that Pat and I will have classified together. And it's really gorgeous 3D chondrules on this stone.
Not joking.
Those are just hanging on by their toenails.
Right.
Dude, that's crazy. How
I'm
have
really
you not
excited.
plucked one out by now? Just
Pat, pluck one out, man.
Wow.
Yeah, and that's all I got. But chondrules is the best topic, in my opinion, in meteorites. Great show, man.
I'm super glad that we can make you happy because I lay in bed at night thinking like, God, what does Amera need? What can I do to hey guys, thank you to the entire crew for helping me out today. This was fun. It was kind of like an unplanned. We're just like, hey, let's talk about chondrules. that's what we did. So hopefully you were able to see some beautiful art on your screen, in our hands, captured through microscopes, and just realize there's a lot of ways to enjoy the hobby of meteorites. But we are super glad that you came to our channel to watch the crew hangout, and we'll be here again next week. Hope you are too. Good night.